So Jenny, tell me a little bit about who you are and what you do here at Rugeley.
I'm Jenny Davis. I work at Rugeley Power Station as a control and instrumentation craftsperson.
What does that actually involve then on a day-to-day basis?
It involves maintaining the power station and fixing breakdowns and modifying the plant when it's required.
So could you talk me through the processes that are involved in making electricity here?
The coal comes in via lorry or by train to the power station, which is then stored on the coal stocks until we need it. And then when we're ready for the coal, it goes to the mills, which is then ground up to a flour-like consistency, which we call PF, pulverised fuel.
The pulverised fuel is burnt in the boiler, which heats the water up to 360 degrees Celsius. How do you get it to such a high temperature?
We increase the pressure, which increases the boiling point.
The steam is itself heated further to 565 degrees Celsius, at which point it becomes what is known as superheated. And what does that mean, superheated?
There's no moisture in it.
What makes the moisture come out?
We increase the temperature and the pressure in the boiler process, which takes all the moisture out, and it increases the energy in the superheat stream.
So by having it dry, it has more energy in it?
Yes.
So this superheated dry steam goes into the turbines. What does it do there?
The steam turns the turbine at 3,000 RPM, 50 Hertz, which every power station in the UK does, because we're all connected to the same system at 50 Hertz via national grid, and we all have to be at 50 Hertz. So
the turbines turn, what are they connected to?
They're connected to a generator alternator which produces 22 kilovolts, which then goes to a transformer which is stepped up to 400 kilovolts to the power lines.
Why do you step up the voltage from 22 kilovolts to 400,000 volts?
It reduces the losses in transmission.
Only in the latter part of the 20th century did scientists discover the environmental impact of using ever larger quantities of fossil fuels. And because of this, a series of laws and restrictions have been placed on the electricity industry to help control the emissions that take place in the process of making electricity. Now, for some power plants in the UK, these restrictions are so strict that they've decided to close down rather than invest in the plants and the technology required to meet those new environmental standards.
Rugeley is one of the power stations that has invested in new equipment, housed inside this building here. It is called a flue gas desulfurization process, or FGD for short. To understand the FGD process, we need to investigate the chemistry of coal. So Chris, tell me about yourself and what you do here at Rugeley.
My name's Chris Hughes, I'm an assistant unit team leader and I operate the FGD plant.
And the operating of the FGD plant, what does that involve on a day-to-day basis?
It involves the day-to-day running of the plant and the monitoring of the emissions.
And what kind of qualifications do you require to work here at Rugeley?
I have a HNC in mechatronics and I'm currently studying a degree in electrical engineering.
And that degree that you're studying, is that part of your work or is it done away from the workplace?
I'm doing it away from the workplace as part of a career development path.
So tell me about the constituents of coal.
Coal's made up of hydrogen, carbon and amongst other constituents, sulphur.
And the burning of coal releases certain emissions to atmosphere, is that correct?
Yes, CO2, sulphur oxides and nitrous oxides.
Now, I know there's restrictions on all the emissions to atmosphere, but I'm particularly interested in the problems with sulphur. Why is sulphur such a problem?
Sulphur oxides in the atmosphere contribute to acid rain.
And you have to remove the sulphur here at Rugeley?
Yes, we do. It's done in the FGD plant.
And how's that done?
As the flue gas passes down the ducting and into the absorber, we spray limestone slurry through the gas, which removes the sulphur and produces gypsum.
It's quite noisy in here, Chris. What's going on?
The absorber slurry is being drawn out of the absorber. It's being pumped down the pipes, through the cyclone, and then deposited on the end of the conveyor.
And this conveyor belt is moving the gypsum down. It's quite noisy though underneath it. What's going on?
There's a vacuum underneath, which is drawing the moisture out of the gypsum.
So it's wetter when it arrives, and as it moves down it gets drier.
Yes, it is.
So the dry gypsum then, what happens to it at the end of the conveyor belt?
As it goes off the end of the conveyor belt, it drops onto another conveyor and is transported up to the gypsum silo.
Right. This display show us?
This display is showing us the amount of gypsum that's being produced an hour.
And it's saying, what, about 15.5 tonnes, is that correct?
Yes, about 15.5 tonnes an hour.
And how much of the sulphur does this process remove from the flue gas?
The FGD plant at Rugeley removes about 96% of the sulphur.
96%? Now, 96% is pretty high, isn't it?
Yes, it is quite high.
And is it better to use coal with a lower amount of sulphur in it?
The plant is designed to run on coal with 1% sulphur in it.
Is that low sulphur coal or high sulphur coal?
That's fairly high.
Oh, high? So why do you use high sulphur coal then?
Because the FGD process won't work if the sulphur content's too low.
Right, okay. Where are we going?
Okay, to get up to the gypsum silo, we've got to follow the conveyor up.
Okay, let's do it. Over there.
Long way up, innit? We're about 20 metres up now, on top of the gypsum silo.
Right.
The gypsum's travelled up the conveyor and is deposited in the silo, just through the door.
Okay. What's going on in here?
Gypsum comes down off the conveyor above us to the silo below us and is deposited out.
But why is the floor moving? It's moving below us, isn't it?
As it's finished moving a layer out, it has to move around to build the layers up.
So it's building the gypsum up to the top of the silo in kind of layers?
Yes.
Right. So what happens to the gypsum in the silo?
Eventually it goes off site and it's turned into plasterboard.
And are we stood on that gypsum now?
This is the gypsum, but a small amount of it isn't high enough quality and it's rejected and ends up here. The amount of gypsum that's rejected is hardly anything. You know, upstairs we saw there was 14 tonnes an hour produced, which was good gypsum. And there's probably 4 or 5 tonnes in here, which has been rejected, and it's been in here for a couple of months, so...
So it hardly rejects any, the
Hardly
process.
rejects any, yes.
Right, right. And if you think that's a long way up, the tower is nearly 200 metres tall, and we're already halfway up it. These 2 chimney stacks here come from the FGD. The treated flue gases come to these 2 chimney stacks, and the gases are vented to the atmosphere. So, with 200 staff and 2 500 megawatt generators, Rugeley Power uses coal to generate electricity all year round. Now, the staff generate that electricity with 3 key areas to consider. 1, it's got to be reliable. 2, it's got to be cost effective. And 3, they have to consider ways to reduce the environmental impact. Now, industries like this one are going to require a new generation of engineers to come along to ensure that electricity flows as long as we human beings rely on it.